Welcome, let's begin. Whilst people are joining the webinar, okay, we'd like to welcome you to a new seminar organized by Argentina, by Climate Madrid. I'm Carlo Mauricia, and together with Romina Cosica, we're going to talk about in the scientific and technical areas in Argentina. We're going to organize this meeting. Next slide, please. So, for those of you who are not familiar with My Climate Risk, this is an initiative, one of the main activities of the World Programme on climate initiatives, and its objective is to integrate and have an approach from bottom up on the region, which is based on the context, and it allows us to introduce in this context the climatic information that's relevant. My Climate Risk is organized as a network and practice communities that each work in their specific context, that share know-how and resources in order to move towards a single objective. At the moment, we have 14 hubs on a global level, and as you can see here, at the moment, there's just one hub in Latin America. But this may change if other communities of practice join this activity. Next slide, please. Next slide. So therefore, in the case of the Argentina Hub, we are 20 students, teachers, researchers from different disciplines. We all work to build relevant knowledge for society. And from the start of 2022, we have regularly met in order to put together our common knowledge as an interdisciplinary team with regards to what we understand as being the main concepts of My Climate Risk. Next slide, and I'll give the floor to Romina now. Thank you, Carla. Welcome to this third seminar of My Climate Risk Argentina Hub. This seminar of today is the third of the cycle called Climatic Knowledge Accessible for Knowledge, or Actionable Climate Knowledge. This is to get to know novelties and to access the material we saw in the last seminars, and we are going to share this with you shortly. Next slide, please. In the seminar today, we are going to look at the sources of information and the lines of proof that is used to build climatic knowledge. We ask ourselves whether the science is objective or whether it includes the values of those that do the research. And so we're going to listen to those who are part of our regional Argentinian hub, who will show us different approaches in order to answer this question and to ensure that the knowledge that we are building is relevant for society. And so the sources of information we choose are important. I'm going to go to the first speaker, Anna Sorensen, who is a geophysician and researches oceans from the University of Buenos Aires. Anna is a researcher from the National Council of Scientific and Technical Research, and she was an author coordinator of the 6th report of the IPCC and is in the Argentinian Regional Hub on My Climate Risk. Please leave your questions for the speakers in the section on Q&A. The chat is only for technical issues. Thank you very much. Can you see the presentation? Yes, perfectly well, thank you. Hello, and thank you very much for coming to this webinar, which is about the sources of climatic information that we use in the physical science on climate. And we, the researchers, use this. And firstly, we want to understand how our values and our context have an influence on when we select the sources of information in order to carry out a climatic study. To introduce this subject on the values and context that make us up as researchers, I'm going to give you some general outlines, and I hope that I can give you some examples, and then we're going to concentrate on the analysis of sources of information that are used by the researchers in their research. As for the values and context, as scientists of the exact sciences, physical sciences, we tend to believe that we are objective in the sense that we are looking to represent reality and truth. On very few occasions, though, we don't stop to think about how the values we have in our principles have an impact on our searches. And sometimes we are able to see how this has an impact on the context, the resources, for example, that we have, whether these be human or material in nature, what the scientific system requires in terms of publications. And so therefore, I'm going to start giving you a very straightforward example about values within the scientific context. As we know, global warming will increase with future emissions. In the IPCC on climate change, 5 scenarios on emissions were studied as global models on the climate. And in the scenario with fewest emissions, which is this one here, in light blue, this is the result of a speedy reduction and sustained reduction globally. The temperature here, as you can observe in this second table, remains at 1.5 degrees during this cycle, and therefore the countries will meet their objectives that they set in the Paris Agreement. But in the worst case scenario, we would reach a temperature, a global average temperature of about 5 degrees by the end of the century. In order to study regional climate change, this scientist is going to use the results of some global models in order to do a reduction in scale with a regional climate model. And in this way, we hope to know more exactly what the changes will be in extreme temperature changes and rainfall in the region. So the context is that there is a limited amount in the disk space that prevents you from using all the scenarios. So we can only use 2 scenarios here. Which 2 out of the 5 scenarios will be chosen, therefore? In order to know this, she consults with her colleagues in the laboratory. Colleague 1 says that we're going to take the worst case scenario because it will give a strong signal in the model. Colleague 2 says, no, we should include the other scenarios in a consistent manner with the Paris Agreement, because otherwise we scientists, if we don't study all those scenarios, nobody's going to think it is possible to achieve the targets. And then colleague 3 says, well, it seems more probable that we should use the average, which is safer to study the middle scenario. So we can see here that these different opinions are based on values. The study that this scientist carries out may simply be for scientific purpose, i.e. to publish a paper. Nevertheless, in my climate risk, what we aim to do is to develop and integrate a bottom-up approach of regional climatic risk, which is based on the concept and scale of decision makers. So therefore, when we want to produce relevant information for society, not only do the values and the context come into play as scientists, but also the values and context of those people and communities that may integrate this knowledge so that we can then contribute these to the decisions taken. So I'm going to give you a very straightforward example. in order to illustrate a situation where the context and values and society and researchers may vary. So this example is on the global, on the temporary horizons of the scientists. This is the same table showing the global temperatures in this century. Historically, scientists, we always provided information for the end of the century. Why? Well, because it's easier to differentiate between different emission scenarios, and it's a good motivation for politicians, global politicians, to reduce emissions. Climate change is a fact, and temperatures is at 1.1 degrees. And so it can be understood that adopting mitigation measures requires information to be able to take decisions, to be able to adapt. So therefore, nowadays, there is an approach for the middle of the century in the last IPCC report, at least. Working on the IPCC, I realized that scientists in Europe were very interested in this because they were in touch with stakeholders and with users who requested this information in order to plan infrastructures. This is something that I had never stopped to think about or come across in my Argentinian context. In addition, for these temporary horizons that are closer to us in time, there may be many societies or sectors that require information. And for us as scientists, it's very challenging this because there's no uncertainty in terms of the scenarios. And in fact, in the last IPCC report, it says that during the last or in the next 20 years that come, we will reach a temperature increase of 1.5 degrees on average, globally speaking. And therefore, what rules these regional climate changes are not mitigation actions or measures, but rather the internal climatic system, which is more difficult to forecast by scientists. And not only because of this do we need to focus on this, but if our spokesperson or if our users require information in this sense, there's no point in us producing information for the end of the century. There needs to be a dialogue to see how we can work together in order to provide the information that is user-friendly. In fact, there is literature out there that talks about a discrepancy between the climatic information and the political cycles lasting 4 to 5 years, and in particular in developing countries. This is an example whereby we need to take into account the context of the user. I'm now going to focus on the subject of today, which are values and context in terms of the sources of information. This table here is a document related to the IPCC AR6, Group 1, Chapter 10, FAQ 1, Frequently Asked Question, number 1. And this is a chapter where I worked within the IPCC. And here, what this chapter suggested as a result of the assessment of many publications is that the information for society should be built in a better way or put together in a different way and integrating different sources of information. Below, we can see the different sectors within society. Here you can see observations, simulations, processes, and high-impact events. And here's a more detailed list of the different sources that we use as scientists. For example, We can use different sources of observational data in situ, grid or satellite. We can use global dynamic models, regional models, or models with explicit convection, statistical models, the understanding of processes, attribution studies, and a lot more on. In fact, in Latin America, we're using the knowledge of the users and the know-how of native communities. Nevertheless, here we have a series of questions that we would like to raise within this seminar. And the questions are, why would I choose a particular source of information? Well, in our opinion, one chooses the source of information that in general has to do with the education of oneself. If you've studied a PhD, for example, with a director who used these global dynamic models, then you would tend to use that tool and believe that that tool is the best tool to use. Or I believe that maybe the hyper fine scale is the best way to go about it to get more exact or precise information. The same happens with observational data. I might not be used to using satellite sources. I might use in situ or grid systems. And the question, though, is whether all sources will provide the same result and whether all the sources are suitable to resolve problems. So from within our hub, we hold the philosophy that it is necessary to use the source of information that is suitable for the problem that needs to be resolved. So if we have a problem that we need to face up to and we don't know what this is, we might think we may need satellite information for that problem in particular. And in that case, we'll talk to our friends or researchers that we don't know and attempt to collaborate with them in order to have the correct sources and to use different sources of information to put this information together.
Thank you very much. Thank you very much. I will now leave the floor to my colleagues. Thank you, Anna, for your presentation. Please remember that we will answer all questions at the end of the presentations, but you can nevertheless type the questions in the Q&A section for Anna and for the rest of the speakers, and all questions will be answered later. Now we have our next speaker, Nadia Testani. She is doing a PhD at the University of Buenos Aires in Argentina, and she is the regional representative of young researchers in Argentina as well. So the same applies to Nadia. While she speaks, you can type your questions in this Q&A section. And remember that the chat is only for technical questions. Nadia, the floor is yours. Hello, everyone. First of all, I would like to thank you for giving me the opportunity to be here today. My name is Nadia. I'm a PhD student. And today I'm going to present a work done with Federico Robledo and Leonardo Diaz, explaining the changes in the cloud cover in Northeast Argentina. We did this during our PhD, and this is going to be an example on the use of different channels of information in order to decide what data to use. My presentation is going to be divided into 4 parts. First of all, I will explain why we are studying cloud cover in Northeast Argentina, and then I will explain how we decide what data to use, and I will tell you if all roads actually lead to Rome. So why should we study cloud cover in the Northeast area of Argentina? As our colleague said, we have to consider our values since the start when we decide what we want to do research on. And therefore, when we take decisions, we also decide what not to study or analyze right now. So we are giving priority to some aspects and not to other aspects. So within the context of climatic crisis, all this is very important. And therefore, the information we develop soon will be available sooner. So we have to prioritize well. We also know that the impact of climate change is generally experienced on local and regional scale. And it is mainly here where decisions are made. And therefore, climatic information here is considered relevant at regional level. Therefore, we have been focusing on the northeast area of Argentina, one of the regions in our country. This is a decision influenced by the context we live in. And wow, why northeast of Argentina? Well, in this area, we have the highest and biggest production area of rice in Argentina. In particular, in the province of Corrientes, nearly 50% of the rice production is concentrated. And we also have to consider other previous research that show the different variability patterns in the region. And we have also seen changes in different variables such as precipitation a long time. Why did we decide to study cloud cover in particular? Well, in the year 2016, within a process of knowledge anticipating for the flood, some producers and farmers of the area said that many losses had been taking place due to cloudy days. In 2023, the use of different models was applied in order to see the effect of cloud cover. Of course, water is important for plants as well as temperature and other variables. And one variable that is rarely applied by the scientific community, such as cloud cover, seems to be very relevant for all Argentinian farmers. That's why we decided to analyze the role of cloud cover and what data to use in our research. First of all, we decided what data you have. Cloud cover. We usually apply satellite estimates in order to understand the cloud cover. Let's see the information in detail. Here we have a picture that shows the ISCCP project. This project uses cloud cover data from the radiance of different satellites. Each pixel accounts for 10 kilometers and is labeled as cloudy or non-cloudy. And then each grid covers 100 kilometers. And within each grid, the percentage of cloudy pixels is calculated. All these data are available since June 1987 till June 2017. Of course, there is uncertainty due to homogeneity on the long run, and then how the cloud cover is made. Because, for example, how do you consider that a pixel is absolutely cloudy? We cannot underestimate other factors. And then there are other research that show that we have to be careful with the variables we use. On the right-hand side of the screen, you can see a map of the region. Each blue point is part of the grid we have devised. Before satellite observation, the only way we could achieve or attain data was through visual observations. How do you do that? First of all, the sky is divided into 8 parts, all the visible part of the sky. And then you see how many parts are covered by clouds. For example, if 2 of the parts are partially clouded, that is 1 octa, and then you would have 2 octas. If there is a portion of the grid with clouds, it is 1 octa, and if there is only one portion without clouds, then you would consider 7 octas. This is still done nowadays, and we have data since March 1961 up to date. So the period covered is much longer than the period covered by satellite observations. On the right-hand side, the red dots show the meteorological stations in our research. And here we can see one of the first limitations of our research, that is spatial coverage. And then there are also inconsistencies due to changes in spatial locations, and then we have the subjectivity of the observer. Therefore, the academic community very rarely uses these observations on the surface due to the subjectivity of the observer. I'm going to make a few questions to you now, and now you can use the chat of the Zoom screen. I will pose 3 questions. The rest of the questions will be for the Q&A chat. First, can you write on the chat box how many octaves you think there are in this picture of the sky? 0, 0, 0. Okay. Well, everybody agrees on the fact that there are 0 octaves, at least on the portion of the sky you can see on the previous picture. Now, how many octaves can you see in this picture of the sky? 8, 8, 8. Okay. We are all in agreement that the sky is cloudy and there are 8 octaves. Now, this is a bit trickier. How many octaves can you estimate or calculate in this portion of the sky? 2, 6, 1, 2, 3, 1. Most people are saying 1, 2, or 3 octaves. Of course, these observations are more or less certain in these cases, but nevertheless, we all agree on the fact that the cloud cover was less than 3 octaves, and we are not experienced observers of the sky using this system. So, of course, there is uncertainty and subjectivity, but nevertheless, we decided to use these data because we think that we can take into account uncertainty as we do with other parameters. What can we learn about these 2 sources of information? Let's see changes in cloud patterns in summer, which are very important for crops. All values are negative here. On the figure, we can see satellite coverage in Argentina between 1983 and 2006 are negative during the summer. And we see that cloud cover is diminishing with time. The trend is significant at 95% confidence. And then we can see that the trend is going down at 99%. What do the surface data tell us? Before continuing, I would like to say something else. In order to analyze all this, first of all, we have a methodological challenge. We had to define a new index of cloudiness, considering the different octaves 0, 1, 2, and 6, 7, 8. we had to establish percentages in order to study the changes and variability of service data. And then the information achieved is easier to understand by non-experts such as decision makers or local stakeholders, or for experts from other disciplines. And this way, interdisciplinary work is done much better. This is the period 1963-2021, and we see that the cloud cover is diminishing in summer. And we see that the annual trends are negative, and the confidence is 99%. Now, satellite data. Considering this database, we are talking about estimates, and should be validated. But surface data are usually considered differently. But what happens in this case? Can we apply all these to cloud cover? Can we use visual observations and consider them truthful? Therefore, we decided to compare both observations. So the language of the conclusions varies, but not the results. In the figure, you can see the average parameters during the year. We see that the variability is quite similar on a monthly basis, and on the table you can see that variables have 99% for all seasons of the year, especially in the summer, which is the period more important for our research. So considering all this, I'm going to give you some food for thought. One of the conclusions of our research is that having two independent sources of information gives us a better and more robust resource. And we see that the cloud cover is diminishing in the northeast of Argentina. And then we have to decide what values we use and the implications of such values. We also have to consider the data that we use and the type of uncertainty we are willing to include in our research. And then we have to consider that different systems can be used, and the information obtained will be easier to use by experts or non-experts. And then in some regions where surface observations are limited, it is absolutely key to achieve results that can be understood by everyone. And to conclude, I would like to read this sentence by Donna Haraway. What matters is what thoughts, think thoughts, what knowledge, no knowledge, what relations put together relationships, and what worlds globalize other worlds, and what stories tell other stories. And that's all on my behalf. Thank you very much, Nadia, for your interesting presentation. Now we have Lucia Capelletti, our next speaker. She has a degree at the University in Buenos Aires in physical sciences, and she is taking a PhD in that university, and she's also very much involved in the international community of young researchers. So let me give the floor to Lucia now, and please leave your questions on the Q&A chat. Can you see the presentation? Am I sharing the screen properly? Yes, Lucia. Okay, thank you. Thank you very much. First of all, thank you for taking part in this activity. I've recently had the flu, so you will see me taking sips of water very frequently. And now let's go straight to the point. I'm going to talk to you about a piece of research in which 3 people of the hub have been involved. Floods in farm plains, harnessing synergies. Now, just to give you some context, we considered a part of the plains of Argentina, as you can see on the screen. This is a very plain and flat region. It is a leading region for agricultural production, and that is important because most of the money that is coming into Argentina from exports, comes from this region. And we started to analyze the situation since the 1970s all the way up to the 2000s. And we've seen that this region is suffering more floods that have a direct impact on farmlands. And sometimes traffic is stopped, which is a major problem for supply chains. Here you can see some floods that took place in the year 2019. The picture is from 2016 on the lower hand side of the screen. And sometimes floods affect very many houses, as you can see on that picture of the year 2021, and that has a big impact on the life of the population of the region. We have different registers and reports by different agricultural institutions or by different media on the relationship between the increase in the floods in the region and the increase of the water tables level.
This year, colleagues from Argentina, from the cultivation areas of San Luis, in an article, they were able to show, using reports and articles from before and satellite data too, they proved that in the last 20 years, that in fact, the farming areas were more prone to suffering from floods due to the increase in the water table in the deeper areas, and it had gone to levels that were more superficial levels in the present time. In addition, this article describes and suggests that through on-site studies that going from deeper levels in the water table to more superficial levels, that the native vegetation in the area that corresponded to deeper roots and water levels that were deeper were replaced by crops that are generally characterized by having more superficial water tables and crops that had shorter, less deep roots. And so therefore, within this context, and based on the work I was carrying out, we found that the humidity in the soil, the moisture in the soil is key for the phenomenon of floods because it represents the level of water and moisture in the soil. And this measurement can be obtained through different sources of information. And one of the sources of information are the satellite estimates. And these are essential because of the global scope. Another source of soil moisture, the in situ measurements, which, as was already mentioned, the source that is considered to be more trustworthy and is used to validate other sources of information. Nevertheless, each of these sources, both the satellite sources and the in situ measurements, have intrinsic characteristics such as the range of values of the soil. So with the objective of increasing the potential and the coherence of the soil moisture, and also the impact, the analysis and the flood phenomena through this variable, we studied the bias that was included in the intrinsic values of these values, taking into account the soil moisture. So, as I mentioned, the area of the study is within the Pampa area in the southeast, mainly, of the region of Córdoba, in this province in Argentina, which is a region that has a landscape that are fairly homogeneous in the type of use of soil. And as I already said beforehand, it shows a very flat relief and also is a clear season without rainfall, and it also has synchronized crop rhythms. There are seasons for active crops and inactive crops, and it is also a region that it is lacking in irrigation systems. As I mentioned before, it's a region that is subject to flooding because of a sustained increase in the water table levels, mainly thanks to the change in use of the soil. In addition, this region has a not very common advantage in the region and for the country, and that is that there's an in situ grid of sensors for soil moisture. So to summarize, we focused on the soil moisture data of an area in the plains in the Pampas in Argentina, using measurements of the in situ sensors as well as the satellite measurements from two satellites. One is the SMOS, SMOS, and the other the SMAP, SMAP satellite measurements. And this corresponds approximately to a time frame of 5 years. So in order to carry out the different analysis that I'm going to talk about, a representative series of tests were taken. In orange, this corresponds to the in situ sensors, and in green, or rather, yes, in green it's the SMOS, and in blue the SMAP, SMAP readings. This data is to analyze the timeframes of active and inactive crops, which are characteristic in this region, instead of taking into account the conventional crop cycles, for example, summer and winter times. So therefore, as I mentioned to you before, we have intrinsic characteristics, and each of these intrinsic characteristics have an effect on the soil moisture and in the possible interpretation that we can give to this. In this work, we focused on two types of bias and limitations. On the one hand, the first bias that I'm going to talk about has to do with the lack of data that we have in some cases, and where we haven't taken into account this lack of data in some cases, these data gaps, as we call them. So when we come to looking at this data gap, we ask ourselves two questions. What are the situations that can cause these data gaps in the records on soil moisture? And what might the impact be if we don't take into account these data gaps in order to calculate the statistical values that are representative? So I'm going to show this to you using two examples using this. And to be clearer, we have the data gaps for each series that I showed you before in a color map, whereby the color represents the value of the soil moisture in those days, on those days that we have data for, and in white, we can see the non-availability of data on those days. And we want to show the soil moisture. And so it's not only so that the data gaps can become clear, but also because it then shows that the lack of availability of data in our soil moisture data is part and parcel of our tools in order to estimate this variable. Having said this, the first data gap that I'm going to talk to you about has to do with the SMAP in January of 2019. There was a data gap there for the region where, according to the in situ measurements and the SMOS data, is a period where the region suffered from high amount of soil moisture, and also national institutions reported that there were significant floods in the area at the time. In this case, we identified that the data gap was from data of the soil moisture that were higher than the SMAP. So values that were over a certain level should be dealt with as being serious or not taken into account. So nevertheless, these were considered typical data of a region that was prone to these floods. So this data gap has occurred on a date where there were regions, both in the region that we were studying and neighboring regions, where they suffered from flooding phenomena and where the regions were completely covered with water. And so therefore we have to ask ourselves how we should consider this data and how we should consider these values that might show the impact that these variables might have in our region. The second example I'm going to provide is this SMOS estimates approximately throughout a year shows the frequency of data that was expected from the satellite, which was to get data every 2 to 3 days. And in this case, we were able to identify that this low frequency of data was due to the fact that the SMOS data in that time frame was limited and degraded because of electromagnetic perturbations that were external to the SMOS satellite. Apart from the underlying cause, what we were particularly interested in exploring was the impact that this had, because according to the in situ data and the SMAP data, this data gap took place in a very humid time, and this might indicate a bias and have an impact on the representative statistics for this whole time frame. So without going to the technical detail, in order to quantify this possible impact of this type of bias on the representative statistics, we can compare the temporary time frame of the SMOS without processing the data gap versus the SMOS series reconstructed using the in situ data and the SMAP data. So in this way, this data that was not processed showed average drier times with greater variability on a daily basis versus the series that were taken into account of the data gap. And this is important to be mentioned because there are publications and reports and articles that are published regularly that show that the data gaps are ignored or not treated in a correct manner. So with regards to this second bias, this has to do with the location of the in situ sensors that we use for this study. The in situ sensors that were used for this study were installed generally in residential areas that had no crops, i.e. the dominant vegetation in the region, and they were less prone to seeing floods. So we assess the impact on the dynamic that is brought in by the location of these in situ sensors with a area that is not representative of the area as a whole. As for the sensors being located close to residential areas, in this photograph, you can see the location of the different devices in the different regions at different times of the year. And we can see that they are located close to residential areas. We believe that this is done in order to have easy access to these sensors. And this leads not only to the fact, as you can see in these photographs, that they are far away from the cultivation area, which is the dominant surface area, but in addition, they are located close to vegetation that is very different to the type of dominant crops elsewhere. In addition, as they are located in residential areas, the in situ devices tend to be at higher levels versus the plains that characterize the region, i.e., they tend to be in locations that are not prone to flooding. And this is what you can see by the satellite systems, because the SMOS and SMAP values that we study showed that these areas flood at least once during the time frame that is studied, according to the studies. And in this table, we can see the frequency and the presence of water during this time frame. So the difference in pixels between the SMOS and the SMAP that include areas that flood at least once during the time frame of this study shows that the in situ devices are less prone to experiencing the flooding phenomenon. So therefore, just to summarize this situation, we put together this following picture, which shows that the in situ sensors, which tend to be close to houses in orange here in the diagram, because they're close to the houses, they tend to be outside of the dominant coverage of crops, which is typical of the region, and therefore they do not tend to reflect the flooding phenomena. Another key factor is that as there isn't the dominant coverage of crops there, the in situ sensors are not able to capture the difference in the water table in the seasons when the crops are active or the crops are inactive. So in order to conclude, we have the possible impact of data gaps in calculating the pluriannual statistics, and this is important when it comes to taking decisions in public policies. And another conclusion is that the new satellite systems should include soil moisture thresholds that include areas that are prone to flooding. In addition, the bias in the location of the in situ devices doesn't mean that the devices should not be used, but one should make it clear where they are located when it comes to reporting the results. And finally, we underline the importance of using multiple sources of information together with local reports. And just to conclude, I wanted to read this sentence to you, which says that the influence of values doesn't need to be a source of bias or distortion. Sometimes it's appropriate and advantageous. The critical analysis of different range of perspectives of values can help to discover and question different biases that otherwise would go unnoticed. And now, thank you very much to all of you for listening to me. Thank you ever so much, Lucia, for your presentation. And thank you to the three speakers, in fact, for the excellent and very interesting presentation. So now we're going to have a Q&A session. Please remember that your questions should be asked in the Q&A section and not in the chat, please. There is one question. We'll start with one question from Det Shepper for Anna, and we will follow the order of the speakers. So the question for Lucia, you can add to the Q&A section in the meantime. This question is in English. So I'm going to read the question in English, and then I will also attempt to translate it.
I'm curious whether you found any difference in values between Chapter 10 and the rest of the R6 Working Group 1 authors, as your approach was rather different from the rest.
The person is curious to know whether there's a difference in the values between Chapter 10 and the rest of working group in the IPCC report in terms of the authors, because the approach was very different for Chapter 10 versus all the others. Anna. Well, thank you very much for that question. And just to put things in context for everybody, because they may not know so much about this report, what is generally done is that in the IPCC report, a decision is taken as to what the global content will be for each chapter. And then the scientists can decide whether to participate in a chapter or not. In the final report, Chapter 10 was a methodological chapter on how it is necessary to use climatic global information in order to build on regional information that could be integrated in the decision-making process. So therefore, this is a methodological chapter, and I think in my case, for example, I chose that chapter as a first option. One can choose three options, and I was chosen for that chapter. And the scientists that applied for Chapter 10 had particular interest in methodology, whereas other chapters were more in the line of presenting results. So we in Chapter 10, I mean, sometimes whilst we're writing the chapter, what may happen is that we get hooked, and we then, well, the values might have changed because of the literature we have read, or because of conversations we've had, and we held weekly meetings, for example, and we also had a Slack where I served for several years each day for the years that the work for this report lasted, and these were philosophical conversations, and it was really great, actually. And so, yes, I believe that the people got hooked, those people who were working on this chapter, and they may have then had different values to those the scientists that were not particularly interested in methodology and other such things, and wanted more to go to the results.
Thank you very much, Anna. This is a question for the other colleague. If you could explore ethnographically the local or native criteria of cloud cover, or how do you define the concept of cloud cover? Nadia. Thank you. Thank you very much for that question. We didn't explore the index of cloud cover from the ethnographical viewpoint. It would be interesting to do so, but we didn't. At the beginning of my presentation, I presented the situation on rice farmers, and we focused on cloud cover. And we didn't focus on the type of cloud on the time of the day. Of course, we have to carry out a broader study, and it would be very interesting to do so in the future. Thank you for your question. Thank you. Next is Nadia. There are two questions. Julieta Caneva, how was the location of the devices chosen, and who decided to position them? Hello, Julieta, thank you for your question.
Esto fue recontra difícil de rastrear.
We had nothing to do with the location of those devices. They come from the CONAI, a different research center. At first, I studied soil moisture, considering satellite observations, then on-site observations, and there were very many differences regarding the time of the crop. The satellite was capable of providing information on flooding, and then some devices would not detect floodings. And therefore, I started to use high-definition images in order to see where devices were positioned. And we learned that many devices were set up in areas that are not representative of the area. The coverage was not good enough. We have to consider that we are talking about plains, farmlands, and the roots, the big roots of trees were not considered. Sometimes devices were not placed close to crops, but close to residential areas. So we had nothing to do with the location of the devices. Thank you, Lucia. Is there anything else you would like to add? No, thank you. Second round of questions, since we have time. We have 2 questions. You may ask more questions if you like to. For Ana. Thank you. This is the question. What would be your recommendation for the next cycle of work of the IPCC, considering different values and the context of information at a global scale? Well, 2 things in connection to your question. First of all, the selection of authors and the call for authors. Other disciplines should be involved, not only physical sciences. The call should be also made to philosophers, anthropologists, sociologists, in order to include their knowledge and points on view in our report. And then, of course, in order to do so, when we draft the list of content of the chapter, a meeting is held in order to decide the content of each chapter. And I think it is important to count on the opinion of other experts from different disciplines. Other experts should be invited to these meetings in order to decide the content of the different chapters. And then the call should be broader to other researchers. And then we should have a better communication between different work groups. In cycle 6, communication was much better than in previous cycles. But I think we need more human resources, because people working on a specific chapter, according to my experience, have trouble in connecting to other or with other people, because the workload is so big in the end. And therefore, we should have authors, researchers working as links between different working groups in order to enhance consistency. And that's all. Thank you. Thank you, Ana. One more question for Nadia by Ted
For Nadia, have you experienced
Alex?
any difference in values between measurement scientists and modelers?
Genial. Bueno,
Thank
gracias
you.
por tu pregunta.
Thank you for your
En realidad, desde
question.
que empezamos a usar estos datos, estuvimos como muy,
I
por lo
paid
menos yo estuve
a
muy
lot
atenta
of
a
attention
por qué
on the
distintos
reasons
colegas no los
why
usaban.
other authors wouldn't use
La
these
verdad es que por lo
data.
menos yo no noté diferencias entre científicos que trabajan con
I
observaciones
didn't see many
y que
differences
trabajan con
between
modelos.
scientists working with observations and
En
scientists
general,
working with
no son
models.
utilizados y son descartados por la
Very
incertidumbre
often some models are
asociada.
discarded due to the uncertainty.
Y ahí, por lo menos yo he percibido cierto prejuicio a los mismos, que a mi entender tienen un potencial
I
que
think
amerita
we have
incorporar
to
esas
overcome
incertidumbres.
the uncertainty some
Por
models
ejemplo,
pose
en el
because
trabajo
the results
que
are very
hicimos,
good nevertheless.
muestran estar
We can
correlacionados
make
con
other
datos
correlations with
de
other
alguna manera
data
ganando
and
robustez,
overcome uncertainties.
y a pesar de tener la incertidumbre asociada al
The
observador,
uncertainty of the
nos hacen
observer does
confiar en
not
que lo
play
observan.
such a
Además,
big
de
role
vuelta, volver a abrir
in the results.
esta pregunta de si estamos
Are we
dispuestos a
willing
incorporar
to
algunas incertidumbres que
include
tienen que ver
or
con
to
modelos
consider
o con estimaciones
uncertainty
ambientales, de
regarding
alguna manera
satellite
ponderar
values?
lo tecnológico frente
Of
a
course
la
we are.
incertidumbre asociada a un observador
And
experimentado
therefore,
con
we also have to
muchísimos años
consider the
realizando sus
uncertainty
observaciones,
of the results of
eh,
provided by expert observers.
solamente porque es una incertidumbre asociado a la subjetividad
On
del
the one hand, we
observador.
have technology, and on the other hand, we have the subjectivity of the observer. Thank you.
Gracias, Nadia.
Another question for
Bueno,
Lucia.
para Lucía.
We don't see the
Lucía,
name of
no
the
sale el nombre de la
person
persona,
posing the question.
pero
Was it
si te fue
easy
sencillo identificar el
to
motivo de
know
tus
the
hallazgos,
reason
si la información era
of
accesible.
your
Bueno, la realidad es que no.
system? First of all,
Primero
it
fue
was
un poco
difficult to know
difícil
what the
detectar
ATLAB
qué era el
was.
data gap, porque primero
In the case of the
llamábamos la
SMOS,
atención en el caso de SMOS,
we
que
had
sí o sí
data
se
every
tenían
2
datos
or
cada
3
2, 3
days,
días.
and
De
then
repente había un año
in 1
donde
year,
yo lograba ver
I could see
a través de la
on-site information and the
del otro
information from the
satélite,
other satellite, and
lograba
we could see a lot of information.
Entonces, primero dije, bueno, habrá sido un
Perhaps the
error
flood was
de
too
antes
big,
no
and
diagnosticarlo.
that's why we are not receiving data.
Así, dando vueltas
We
al
started
asunto,
to think
logramos identificar que
about
el
all
tema
possible
con SMOS
reasons, and we
fue
saw
por
that there was an
interferencia,
interference
una perturbación externa,
by
pero
an
no fue
external
nada fácil. Fue indagando
factor.
documentación,
We had to
documentación,
talk to many
documentación, y
different
luego,
experts, and in the case of
en
SMAP,
el caso de SMAP,
the
afortunadamente
satellite
el satélite cuenta con una
has
buena
a very good
documentación
documentation
de qué
system.
va pasando cuando, por ejemplo, el satélite
Sometimes
entra en modo
the satellite
seguro
goes
o
into
modo
safe mode
seguro,
or non-safe mode, and then the
y
satellite
además
provides
tenemos
a
metadata
complete
completa
metadata.
que en este caso, como también el data se dio en un
And
periodo muy
during a
húmedo, me
very
pregunté por qué no lo
wet
veíamos
period,
en las dos
I
fuentes
wondered
igual.
why aren't
Justamente
we
SMAP
receiving
tiene
all
ciertos
data?
valores, hay que, según la misión, habría que
Some
ver
data
cómo
shouldn't be taken into
incorporarlos o
account.
tenerlos en cuenta. Y entonces,
And yes,
sí,
it
uno de
was
lo que fue
complicated.
complicado del
It
trabajo
was
que hicimos
difficult,
fue llevar
very
adelante, bueno,
challenging.
qué son estos data gaps
Analyzing
y si
data
son
gaps and
relevantes.
their
Y nos
relevance
dijeron, bueno, en el caso de SMAP
was a huge
sí, porque de
task
repente no tenés
because sometimes you
información
don't get
sobre la humedad,
information on
justamente la humedad es
soil
un
moisture,
indicador de
and there's
evaporación y no
been a
tenés esa
flood.
información para analizar dicho fenómeno.
It was challenging,
Pero
but
bueno,
we
fue
made it
difícil, pero se
nevertheless.
logró.
Thank you, Lucia.
Bueno, muchas gracias, Lucía.
Another question
Pasar
now for
a otra
Ana,
pregunta que es para Ana o en
or
realidad
for
para
the
también si
rest
quieren
of the speakers,
contribuir
Nadia
después
and
para
Lucia,
Nadia y
by
Lucía,
Gaby.
que la hace Gaby. Y la pregunta en inglés: How would you deal with potential different outcomes of multiple lines of evidence, especially with regarding to values of scientists and the values of those stakeholders that may use the information? ¿Quieres empezar, Ana? Y vemos si las chicas quieren contribuir también.
Thank you. That's a very good question. We mentioned all this in chapter number 10. When we see different results coming from different evidence, in chapter 10, we explain how important it is to explain this situation. If two sources of information don't provide the same result, then it is probably because one of the sources is flawed. So we have to learn the flaw. It is important to be able to communicate and to tell people which source is better. And we have to continue to research and to learn why different sources of information provide different data. Like Lucia said, we need to understand why. I have an example, and since we have time, I'll give it to you. A South African group can't remember the name right now.
Leonard.
There are many groups in South Africa, and I don't know all the names. There is a hub in South Africa, spearheaded by Chris. They did some research with decision makers in Lusaka, in Zambia, I believe. In that research, different models are being taken into account. There are two forecasts for the future, with more and with less rain, and everything is very confusing. Which model should we pay attention to? The more rainy one or the less rainy one? And of course, what should decision makers do? Because we still don't know why we have different results. So they were working with different decision makers and they wanted to know how to use the information. And users said, well, if it rains more, it doesn't really matter. But if it rains less, we do have to take measures. And therefore, they were able to discard part of the information. We don't know if that information was true or not, but it was not useful, because if it rained more, it didn't matter. And therefore, if you work with users and decision makers, you can solve many problems. Thank you, Ana.
Muchas gracias, Ana.
Nadia or Lucia, is there anything you would like to add?
Algo desde su perspectiva.
Otherwise, I think we should go for another question, which is for all three panelists by Shepard. The question is in English.
También en inglés. How do you represent reanalysis to users? There are no data gaps and the data are easy to use, which makes reanalysis appealing. Some scientists have tended to dismiss reanalysis entirely for long-term trends, but there are counter arguments to this position. It seems a challenging question when dealing with non-specialists. No sé si alguna de las
Would any one of you want to answer? Yes.
Sobre el análisis,
I haven't worked with users in the case of analysis, but what I would do to start with is to explain the pros and cons of this method.
Lo que sí, en cuanto a reanálisis,
when I work with European scientists, I see that they rely very much on analysis.
Yo supongo que confían mucho en el reanálisis porque hacen un buen trabajo para Europa.
Because they are doing work for the area of Europe.
Con ellos y quieren aplicar ERA 5.
Region number 5.
Yo siempre digo, no, tenemos que usar la versión de ERA 5 que está correccionada por
And I always tell them, we have to use the bias corrected version. And they say, no. And I always insist that. And then we run a test and we check the bias corrected version and we see the rest of the outcomes. And that's when they see that there are other ways to do things. And in the end, we only use the variables that can be, whose bias can be corrected. We should never reach wrong conclusions in our research. For example,
por ejemplo, si yo quiero estudiar, que es un trabajo que estamos haciendo, si yo quiero estudiar la coherencia de fuego,
if I want to consider the probability of a wildfire, taking into account soil moisture, we have to have a proper and sound analysis. Thank you, Ana, for your reply. Nadia or Lucia, is there anything else you would like to add? In the Q&A box, someone mentions the group, working group, climate system analysis group from Cape Town in South Africa, the hub you mentioned before. So thank you. So I think we have replied to all questions. I'm going to give the floor to Romy.
Okay, we have about 5 minutes left for any questions you might have. I just want to remind you that you can access the website of this hub if you want to add the details to the chat again, and you can access the past seminars too. And so we'll adjourn this third seminar. Thank you very much to all of you for having participated. And you'll see on the screen all the information, and we will look forward to seeing you for the next seminar on the 27th of September in order to focus on another subject which is of great interest too, the perspective of climate risk, and it is the experience, practice and co-production and actionable climate knowledge. So thank you very much to all of you, and we'll see you again soon.